Hello, welcome to the second lesson of week 2, 2.3. I changed my glasses, so I must be recording this at a different time than the first lesson. Not true. Anyway, I'm going to go a little faster through this lesson, less explaining, hopefully, but you guys know me. Maybe I'll get caught up in the moment and need to explain more. Hopefully not. Let's go. All right, so we're on number 4. We are going to look through, it says it's about an Uber, something we can all kind of relate to. When you don't have a ride and you need to get somewhere, you can almost always get an Uber or Lyft or a taxi. But not all rides are created equal. Sometimes you need a short ride. It doesn't cost a lot. Sometimes you need a longer ride and usually more expensive. Suppose a passenger in an Uber has looked at the cost of their rides. What if a ride went for 4 miles and cost $12.05? Also, a ride could be 7 miles and cost $19.40. Assume that the cost per mile is the same. So basically they're saying assume that it doesn't matter if you go 50, 100, 1,000 miles, each mile costs the same amount. Now, this is an example where X is not time. Ooh, I told you it was coming. Usually X is time. In this case, it's the number of miles. All right, so let's write out our coordinates, 2 coordinate points. Hopefully by this point, you guys are realizing that these problems are kind of following the exact same pattern every single time. So it's a snapshot. If you are at, oops, all right, sorry, had a little bit of a glitch there, but here are the 2 points that we get from the question, and here's our y coordinate represents, x coordinate represents. Since we're getting better and better and better at these questions, we don't have to work quite as hard. So x coordinate represents the number of miles that the car has gone, and the y coordinate represents the cost of the ride, or dollars. So this is me getting more and more lazy, and I hope you can come on my lazy mathematician journey with me, because great mathematicians are very, very lazy. All right, so calculate the equation of a line. Again, we're going to set ourselves up for success. We know we have 2 parts to this. We need to find the m, we need to find the b. Let's do it. So the m, it comes from subtracting the x's on the bottom, subtracting the y's on the top. The y's are 1940, subtract 1205. The green is the x's, 7 minus 4. All right, and we are going to put that into our calculator because you know what? We're getting so good at this. We might as well okay, sorry, another little mistake there. But, so it says 2.45, that's $2.45. I'm going to change it into a fraction, and I'm looking at this fraction, and it is a nasty fraction. So instead, what we're going to do is we are going to press that button again until we get that 2.45 back, and we're going to use the decimal this time, and we're going to see what happens when we have a decimal instead of a fraction. All right, part 2 to finding this is to solve for b. So again, we have to write y equals mx plus b. We're going to use the first point. The y comes from the point. The x comes from that first point. And then we know that we just solved for the m. So that's the m. We're going to solve for the b. So the y is $12.05 from the point. The m is $2.45. Remember that you're always multiplying if you have 2 numbers next to each other. And then you're going to do times 4. And as we're solving for b, we need to multiply first before we solve for b. So we have $12.05, $12.05 is equal to $9.80, or 9.8. You don't have to put the 80 there, plus another number. We're going to solve for b by subtracting 9.8 from both sides. Remember, we create 0 there. Add from top to bottom. We get 12.05, subtract 9.8, and we get 225 is equal to b. And again, when we're dealing with money, a lot of the time it's going to be more convenient to use decimals, because when we talk about money, we use decimals. So keep that in mind, that sometimes we switch back and forth between using decimals or using fractions, and it kind of just depends on what you use in real life. All right, so we've seen this question quite a few times. Let's get after it. What is the y-intercept? The y-intercept is the b value, 2.25, and since it's a y value, it is $2.25. So it's a starting amount. The starting amount is how much your ride will cost at the start of the ride. So you can think about this as, if an Uber picks you up and it's only going to take you a block, it's still going to charge you a fee just for picking you up, right? It's not just going to drive all the way to where you want to get and then pick you up and then take you to where you're going and charge you 25 cents, right? It has to have a base fee. So this is like a fee for getting in the car at all. So you could say something like, even if you don't go any miles, so 0 miles, it still costs $2.25. And you can think about that too. If you've ever taken an Uber and it has not been able to find you, or you missed the call, or whatever happened, you fell asleep, something like that, they're still going to charge you, it's like $5 or whatever, just for having to show up at your, wherever you are, even if you weren't able to find them. So it's kind of like a fee just for arriving at your place. All right, so what is the slope? Remember, slope is m, so slope is gonna be 245. And what does the slope represent in this problem? So this one's a little tricky because we're not seeing a fraction. We're going to do something that maybe you remember from trying to figure out a rise over a run, or graphing, creating a slope triangle. We say it's over 1, even though there is no number underneath it, because it's a secret one. Any number can be divided by 1 and be the same number. Now we're going to think about the y units, which is money, over the x units, which is miles. And now it becomes fairly clear. It is $2.45 per each mile that you go in the Uber. So a few different ways to write this sentence. Again, no big deal if you write it a different way, but you could say it costs $2.45 per mile to take an Uber. Seems, I mean, not a bad price, right? About $2.50 for a mile. I paid $2.50 to get on a bus. You know, not a terrible fee. All right, let's get to the rest of the questions. It says calculate the x-intercept of the scenario. Remember, x-intercept is when we have 0 equals mx plus b and we solve it. And why does this x-intercept seem unrealistic in this scenario? So like what happened in the last video where it was like, okay, I see the x-intercept, but it doesn't actually make sense in real life. So we're gonna have to pick apart this answer. All right, so here it says 0 equals mx plus b, 0 equals 245. We know that x is what we're solving for, and then we had 225 for our b. And we're going to minus 2.25 minus 2.25 from both sides. That creates a 0. We always add top to bottom. Negative 2.25 is equal to 2.45 multiplied by x. Even though it's a decimal, don't be scared. Don't be scared of that decimal. You always just, you just divide by whatever number is in front of the x. If it was a fraction, we use that special strategy. Wow, my language is not doing so good today. Dividing top to bottom. And we get a number that's not a very realistic number, negative 0.92 if we were to round it. And x is in miles. So, you know, what they're saying is that the x-intercept is where it should usually be an end point. But another way to think about it is when y is equal to 0. And so when y is equal to 0, we know, looking back up, it's when you've spent $0. So you know, they're saying like, how could you spend $0 to get in an Uber? You can't, right? In order for the Uber to just even think about coming to pick you up, it has to charge you a fee of $2.25. So the x-int does not make sense because Ubers always cost money, right? They're never going to be negative miles. Like, you're never going to get an Uber ride for $0. And that's what this question was asking is, when are you going to get to $0? Never, if you're taking an Uber. That's why this answer is so ridiculous. All right, last couple questions here. Again, we're picking out whether this is an X or a Y. It says you need to travel 13 miles. That's a pretty long Uber drive. We know that miles is X. So writing out Y equals 245 times 13 plus 225. All I did was just replace X with 13. And again, remember this trick. You can just put the whole question in at once. So we have y equals 34.1. We're talking about money. So we know that an Uber ride that is 13 miles will cost $34.10, which from my experience seems pretty realistic. Taking a Uber from Minneapolis to St. Paul, I've done it a few times. It costs about $30 more money if you're going to a concert or something like that, which I've done a couple of times. All right, next one. It says at a cost of $42.92, how far will this ride take you? So again, this is giving you a y value, so 42.92. We know the m value is 45, x, and then we know the b value, sorry about that, is 225, and we need to solve for x. So this is just a two-step problem. Don't be scared of all the little decimals. We're just creating a 0 here, adding from top to bottom, 42.92 minus 2.25. We get 40.67 is equal to 2.45 times x. To get rid of that 245, we divide. Hey, that rhymed. And here we go. So we're just dividing that answer by... All right, sorry about that. Again, lots of mistakes today, but when you divide, you get $42.92, which will get you 16.6 miles in an Uber. Looking down at the next question, remember you're going to enter your equation into Desmos. You're going to click the wrench and put in these parameters for x and y. You're going to put in the points from part A, and you're going to tap on the x-axis and the x-intercept and the y-intercept and enter in your graph to check your answer. Good luck, you guys, on the next question, number 5.